Hola chamas y chamos, welcome back to Álvaro Dev Labs. I'm still hyped about the fact that I gave a conference talk at Nuxt Nation last week around a lot of cool people and amazing speakers in the Nuxt environment. And what I want to do today is actually expand that talk that I did about how to add 3D to your Nuxt application using ThreeJS, because I only had like 10 minutes. It was a lightning talk and it was really difficult to cover all the details. So today we are gonna do that. We're gonna go a little bit deeper into the topic and see how Nuxt can help us having a better performance on our 3D experiences. So weeks ago, I launched a video about how to add 3D to your Vue application that you can check on the channel, and a lot of you suggested or asking me for doing a version with Nuxt. So that's why I also decided to go forward with this tutorial. I want to thank you and all the community for all the help and support that you have been giving me this last year, especially last week with the conference. So everything is thanks to you. Now, let's do some cool 3D stuff in Nuxt. This video is sponsored by Storyblok. If you attended to my talk at the Nuxt Nation, you probably already know Nuxty, which is the unofficial mascot for Nuxt.js that I use for the sake of showing how to load a model, a 3D model into your Nuxt application. If you want to check out the conference talk, I will put the link on the description below. But this is what we are going to do today. We are going to load a 3D model that we create using a 3D software. I created this one with Blender. And then we are going to load it into a Nuxt component that is going to work only in the client. Okay, so first things first, let's create a brand new Nuxt application using the fresh out of the oven stable release. Congratulations to the team. I know you have worked hard for this, so congratulations. We are really happy to have the stable release finally. So here in the terminal, let's go for the folder that you want to install the project, and I'm gonna use pnpm, and this is the command pnpm dlx nuxi init, and we are going to call it Nuxt 3ds magic. So it's gonna install everything. We can see this brand new without any release candidate. And I'm just gonna open it with code. Okay, so after that, I just install everything with pnpm install shamefully hoist. Okay, remember to put the flag whenever you're using Nuxt and you're using pnpm. And I also added some prettier here for the formatting of my stuff, okay? So we have a plain app.vue. If you go to the terminal and you run it, oh, look at that. We will have our application running on localhost. Now let's clean up a little bit the Nuxt application and prepare it for the code. So I'm going to remove the Nuxt welcome and just add Nuxt page here. And inside here, we're going to create a page, which is going to be index.vue. So quickly like this, okay. And let's put it a class, maybe page, okay. And I'm going to create a new component that is gonna hold our experience. Normally I suggest this because it's easier than if you have any asynchronous thing like a model. It's easier to use suspense to load it. So I'm gonna create a component which is gonna hold our 3D experience, which is gonna be called the experience. Okay, really creative today. Let's just put some placeholder here. So here it is the best 3D app, and we're going to import it into the index. So here the experience, just like this, and it's lovely how you can just do that and it will work because you don't have to manually import any component. It's auto imported by Nuxt. Okay, so what is ThreeJS? ThreeJS is a JavaScript library that basically does all the heavy lifting on rendering of the WebGL API to create this 3D experience. So it makes it really easy to use. You have some objects that you are going to create in your instance and so on. And before we go deep into it, let's see some of the examples of things that you can create. I actually love this one. This is like create your own or design your own iPhone. Okay, it's pretty neat. You can also be against the system and put an Android logo like this. It's pretty well done. So you can create all this crazy stuff and change the palette. Let's see, wallpaper, and you can change the wallpaper. That's really nice. Let's see another one. This one, for example, Matbox. Make the word play. Yep. You also want that. Nice map. There's a little bit of parallax there. So everything is like 3D models. That's really creative, to be fair. Okay, yes. So with ThreeJS, you can build things like that. So it's the best option to work on 3D. And also it has an amazing community behind. You can ask in the Discord questions, forums, etc. in the Twitter. They're really nice people because every time I create a tutorial, they basically just retweet it and like it. So I really appreciate that kind of support for content creators. Okay, so going back to our Nuxt application, let's install 3JS. To do that, I'm going to use pnpm add 3 and the types for TypeScript. I already installed it, but you just need to click enter. Also, I installed them as developer dependencies, okay? And after that, we can start. Okay, now that we installed 3JS in our project, let's cover some of the basic of a 3D scene to know what we need to build in the code. If you are already familiar on how scenes are created in 3JS, feel free to skip this part, but maybe you will learn something new, okay? So here I draw as I could a 3D scene, and we have like 3 elements to cover. First, we need something to draw, okay? It's gonna be a 3D object, so it could be a sphere, could be a plane, it could be a light, okay? Those are 3D objects or 3D instances, okay? Then we will need something to see it, which is gonna be the camera, okay? The camera will allow us to transform that 3D space into an image that we will be able to put on the canvas with the render, okay? So the render will need something to draw and a camera to see it. All of this is between a scene, okay? So the scene, you will be able to add a camera, to add a light like this one, or the spheres and so on, and then you will pass it to the renderer, which is going to render on top of the canvas element in the HTML DOM. I hope it wasn't that dense, okay? It's gonna be easy to see whenever we go to the code itself, okay? So let's go to that. We are back to the VS Code editor, and now let's prepare the Nuxt application to hold our 3D experience. For that, I will remove the default Nuxt welcome, and I'm going to put a Nuxt page. We're gonna use pages here, okay? And to create an index page, we just create a pages directory and index.vue. And inside of it, let's create an empty component, okay? And here we are gonna have our experience, right? I'm gonna put like a class here so we know what it is. Nice. And let's create the experience. So I like to put it in a component itself. So here in components, let's create one that is called TheExperience.vue. Why is that? Because sometimes in your scenes you would like to have something asynchronous, textures, models, etc. So in that case you would like to put a suspense here in order to do it asynchronously. In this case we will not need it right now, but later it might be come handy. So we have the experience here, and we initialize the component. And inside of the component, I'm going to put a canvas element. Okay. We will get back to it in a second. Now let's hide the sidebar so we can see it clearer. Okay. And let's start adding the 3D instances to make this happen. First of all, we will create a scene, okay, to be able to add all the objects that we are going to create. To do that, we're going to import a scene from tree. Also, you will see in a lot of tutorials that they do something like this. Import all as tree from tree, and then they create the scene like using tree a scene. Okay, like this. But I honestly prefer to only grab what I need into my experience. So I'm gonna grab only the scene. We're gonna hold it in a variable called scene. Okay, super easy. And now let's add a camera. To do the camera, we're gonna say constant camera equal. And in ThreeJS, there are two types of camera. There is the perspective one and the orthographic one. The perspective is the most similar to the human eye. So you will be able to see things with perspective related to the space. The orthographic one is one that doesn't have perspective. So it always looks kind of the same, like okay? So in this case, let's use the perspective camera, and here you need to pass some parameters. We need to import it from tree, so we can see some of the options, okay? So the first is the field of view, which is like the frustum, vertical frustum that you can see on the scene, and the aspect ratio of it. Right now, I'm going to set it as a fixed one, okay? So 800 width and 600 height, but even though I'm going to do it here. So it's gonna be width 800 and height 600, and then let's use width divided by the height. And this is how much the camera can see, like how near and far can see. So these are the default values that work, okay? Now that we have the camera, we need to add it to the scene. So to add any object to the scene, you can use the method add. So we are gonna do a scene add camera. Okay, we have our first element. What's next? Now let's create a 3D object. To do that, we're gonna create a sphere. Okay, so let's use the autocomplete here. We're gonna use a mesh. Okay, so the mesh is an object that contains geometry. So we pass the form of the geometry that we want to use, in this case a sphere. So it's gonna be a sphere geometry. This is going to say tell the web renderer the structure of all the vertices to form the actual object, okay? And we need to pass a material, the material or the properties that define how the light interacts with the object, what color it is, if it's reflective, etc. Okay, so we're going to use the most basic of them all, which is the mesh basic material, and we're going to pass a color here. I normally use the same color, so 0088. Okay, this is like a teal color. Cool. The same way as we did with the camera, we can add it to the scene using a scene add sphere. Okay, so now we will need to create the render. To do that, we're gonna say const renderer equal new WebGL render. Okay, and we're gonna pass a canvas because we want to render the scene here on the DOM element. So if you weren't using Vue, you probably will need to do something like this. Document query selector canvas as HTML canvas element. But because we are using Vue, we actually could get the reference using templateRef. Okay, so we're gonna remove this here, And in the top of the file, we are going to create, I normally call it experience. And this is going to be a ref of HTML canvas element or null. And we're going to initialize this reference as null. Let's import the type from Vue. Okay, so it's correctly typed. And now in the canvas, we're going to pass experience.value. The thing is that right now, it's going to tell you that you cannot pass a type null. So you need to make sure that you have the reference from the HTML element. Let's do this. I'm going to pass the reference here, which is going to be experience. Okay. And then we need to set the size of the renderer, which is going to be the same as we use for the camera. Okay. And then we need to tell the renderer to render. This method right here is going to render a scene or an object using a camera. So you need to pass two things. You need to pass the scene and you need to pass the camera. Let's see what happens. If we go to our scene, we're going to see that there is nothing rendered. Okay? So let's toggle the developer tools and see what errors do we have here. So it says cannot read property width of null. That means that this right here that we're passing, the experience, is null. So we need to wait for the templateRef to get the HTML element from the template tag. We can do it in several ways, but let's do it in the following one. Let's create renderer as a variable at the beginning, okay, of type web renderer, and let's use lifecycles hooks from Vue to get this done. Here I'm gonna do onMounted, okay, and let's create a function which is set render. So inside of it, let's remove this const and we are gonna pass everything just right here. Okay. Cannot find name renderer. Yeah, because I had a typo. That's fine. And let's put an if here. So if experience value, then do this. Okay, perfect. I'm gonna remove these two here and put it here. Okay. And then whenever it's mount, we are gonna call set render. Okay, let's see what happens now. So let's refresh, and now we do have the canvas element, okay, with width 800 and height 600, okay, and it's rendering something, okay. It's a black screen for now, but it's rendering. Why is a black screen? So this is a common error that happens to a lot of people when they are beginning, and it's because we are creating some objects, but they're all in the center of the scene by default. So right now we have a sphere in 0, 0, 0 in the center and origin, and also the camera is suited there. Since for performance reasons, ThreeJS doesn't render the two sides of an object. So if you have a sphere, you're gonna see the surface outside, but not inside. So what we need to do is actually change one of the properties of the camera. All the objects, all the 3D objects has this argument, which is gonna be position. So you can use set to set the position of the x-axis, y-axis, and z. In this case, let's use 0 for the x value. For the y value, the vertical one, let's put like 4, and let's use 4 for the z. So how far it's gonna be. Let's see if that works. Okay, right now we can actually see something down here, so maybe the value was too much. Maybe it needs to be something like 2. Okay, a little bit better. Let's play more. Maybe we need to set the height to 0. Okay, so right now we are in front of the sphere and we have something rendered. Okay, so now that we have our scene rendered, let's improve it a little bit. Because if we go here, for example, you're gonna see that the canvas, we set a fixed width and height, right? And whenever we scale, it's not really responsive, like it's gonna cut our scene. So the idea will be that it actually takes the whole container, in this case the window size, right? So we can achieve that relatively easy. Instead of having this here, let's say window, okay, inner width and window inner height. The same for this part. So instead of width here, it's gonna be window inner width and window inner height. Let's save and see what happens. So okay, right now it's taking the whole width. We still have this weird margin here, and that's because we haven't set any. My cat is hunting flies, so she makes this sound like I'm gonna hunt you. Mochi! Sorry about that. So let's see. Where we were in the case that we have this margin really ugly right there, right? So it's gonna be off if we create the style here in the app and we say body to not have any margin. That should be enough. Okay, that looks good. But we still have the issue that the render is not being updated whenever we are doing this, because it's getting the width and height at the beginning, right? So let's go back and see what we can do. So we need something that listens whenever we are resizing the screen. Before we continue, there is something important to talk about Nuxt. Is that if you refresh the page after we create this window inner width and window inner height without the hot mode replacement, this is gonna happen. It's gonna tell you, it's gonna give you a 500 error, and it's gonna tell you the window is not defined. And that's because we are serving this as a server-side render. So in that case, we have several options. Okay, we could set in the Nuxt config here that we want to do client-side render. Okay, but imagine that your page is actually a server-side render page, and you still want to render or 3D experience. It is possible, you can do it, but it's not the optimal. So the idea will be to take advantage of Nuxt and use some of the wrappers that exist for this. In this case, let's go to the page here, and something that I love about Nuxt is that it provides this client-only wrapper. If we use this client-only and rewrap the component, it's only gonna render it in the client. It's not gonna try to render in the server, meaning that the window is gonna be available. If we try to reload here, we're gonna see that it's actually working. Another way of doing this without using a wrapper is to, let's remove this here, open the sidebar, and go to the component that we want it to be only rendered in the client. We can use the suffix client, so it's gonna be TheExperience.client.vue to tell Nuxt that this component is gonna be only rendered in the client. Okay, so now we need a way to tell the renderer to update the size whenever we're resizing the screen, because right now it's gonna take the first width and height of the window. To do that, I'm gonna add here another package. So I'm gonna open a new terminal here, and I'm going to add, so npm add vue use core. For those of you that don't know what vue use is, it's an amazing repository with a lot of different utilities, composables for your Vue application. They cover almost everything so you don't need to reinvent the wheel. And we're gonna take advantage of one of them in the experience. We're gonna import something called useWindowSize from Vue scope. So instead of passing the window inner width and the window inner height, we're gonna use this composable to get the correct width and height. And we're also gonna create a computer property called aspect ratio. And it's gonna be a computer property that is gonna divide the width value and the height value. Okay? In this case, for the camera, we're gonna pass here. So it's gonna be aspect ratio.value. And we want to resize the screen every time. So we need to call again this function here, which is called setSize. And actually, let's update it to have the width value and the height value. So we don't need to create it again, but we do need to change it. So let's move this functionality here to a new and say function update render. In this case, we're gonna set it like this, and let's call it the first time that we set the render, let's call it, but let's use a watcher to watch whenever the aspect ratio change to set the correct window size. So to do that, we're gonna put here watch, and whenever the aspect ratio changes, we are gonna update the render. Look what Copilot is suggesting me to do here, because if we don't do this, what is gonna happen is that it's going to update only the render. Okay, so if we go here, we can see that it changed the size, but it deforms the scene. And that's because the camera is not updated to get a new aspect ratio. If we do this, and we save, we are setting a new aspect ratio based on this one, and we are updating the projection matrix. That means that we are updating how the camera sees. So whenever we resize, the scenes remains the same aspect ratio. So that's really important. Let's clean it up a little bit before we go. So we can also create another function, and it's gonna be update camera. Okay, it's gonna be this one, and we just call here update camera. That looks way better. Perfect. Now it comes one of the most interesting and most important topics on 3D rendering in general. Right now, we have our renderer, but it looks like static. And that's true. It's like an image, because we only render once. We ask the renderer here to only render whenever we create it or whenever we resize the screen. So to give it a little bit more life, we need to enter the loop. Okay? So this concept is how video games work, how content creation, videos and stuff. And it's the concept of frames per second. Okay? So the idea will be that we have our sphere in a position, let's say in the center, in the beginning, and at time 0. We render, and then we update the position of that sphere. So we render again. That would mean that we could move our sphere whenever we increase in time. Frames per second means that how many images of your sphere you can fit in 1 second. You probably heard from video games like 60 frames per second. That means that to get a fluid animation, you're using 60 images, or the progression of 60 images, to see the animation of the sphere. When you do in video, you're probably using 23, 24. Then you can be like the new Pokemon games that runs on a toaster with 12 frames per second. To achieve this, we are going to use a request animation frame. And guess what? Vue use already has something that we can use for that. So to achieve that, we're going to use the web API for request animation frame. Let's jump back to the code, and we're going to create here a loop. So it's going to be a function, okay, like this, and we are going to a sphere, okay, let's say position x 001, so we're going to increase it. Try small numbers at the beginning, because if not, it's going to be too fast and it's going to increase the x value too fast, okay? Then we need to update the renderer, okay? But do we need to set the size again? We probably don't. So we could move this only here, okay? So instead of date render, we could use this. That's fine. Then we need to use request animation frame, and we're gonna pass the callback. With this, the browser is gonna launch, or the browser is gonna trigger every frame per second to be able to use this. So whenever we use this function is gonna call the callback with every refresh rate on the browser, meaning the loop is gonna be an interval. If we save and we go back here, it's not doing anything because we haven't called the loop in the first time. So whenever we set the renderer here on the unmounted, we can put it like this. And now you can see that it's moving. Quick, before we continue, some words from our sponsors that made possible this channel. Looking for a CMS solution that is great both for marketing teams and developers? Look no further. Storyblok is the headless CMS solutions that you always wanted to have. See how easy it is to change content for your website with a real-time visual editor, creating a delightful customer experience for your teams. Go from a content update to production in no time. Storyblok is easily integrable with multiple tech stacks, making your dev team's life easier. Go and try it for free at storyblok.com. So for the last part of the tutorial, let's try to replicate the demo that I use in the Nuxt Nation, okay, where we have this model of Nuxty, the cat, and we are gonna add it to our scene, okay? So let's prepare the scene first, because we will need to change some stuff. We will need to add the background to the scene. So let's create a new variable that will be right over here, and we're gonna call it background color. Okay, and this is gonna be new color. It's gonna auto import it from here. And let me find which was the color that was using. I think it's this one. Yeah, something like this. Okay, awesome. Something that I also like to do is create a scene fog. Okay, so whenever you have your scene, you can add this kind of fog that adds a really cool effect to the scene, okay, and it has to go with the same color as the background. So let's also import this from Three, okay, and we're gonna pass the background color. Last but not least, we need to set this scene background equal to the background color. I'm probably setting something in here down below. For here we need to set alpha for the renderer to be true, so that way it will be transparent. Okay, let's see if that worked. Yes, now we have the background the same way. Let's get rid of the sphere for a moment. Okay, and let's try to add the model. To add the model, we are gonna use the GLTF loader. If you go here, I created a new branch that you can check out. It's feature Nuxt model, okay, and it's gonna contain in the public a folder called Nuxt, and inside of it is gonna have a file with extension GLTF. This is a common extension used for 3D modeling. You can find a lot of GLTF, or there is also Object, FAX, a lot of different formats in places like a Sketchfab. You can download your own. But for the sake of this tutorial, I'm gonna provide you one in the repository, okay? It also contains the textures. So for example, the Nuxt shirt is this one, and you can see the baked skin right here, okay? How do we use the GLTF loader? We need to import it from another place because it's not inside of the core of ThreeJS. You need to import it from three add-ons loaders and then GLTF loader, okay? And the way we can use it is just saying GLTF loader equal to new GLTF loader, okay? And then use this one here and say load. And as a first parameter, we're gonna pass where is located our model. In this case, we have it inside public, so we don't have to pass anything first. Then is Nuxt, I think. And then is, let me check, Nuxt GLTF. So it's gonna be Nuxt GLTF like this. Okay, awesome. Now our GitHub Copilot auto-completed something like here, and the idea first is gonna be, let's just comment this and see what comes from this callback, right? So let's prompt GLTF and see what it is. Okay, let's go here. So we have our blank page, that's fine. How can I toggle the developer tools? Nice. Okay, so sphere is not defined. Oh yeah, sorry about that. We were updating it in the loop and we no longer have an sphere. So now we have an object. This is a GLTF, and you can see that it's a GLTF because it says on the generator a Chronos GLTF blender, okay? And we have the parser and the scene. So there are two things. There are a scenes and a scene, okay? It's a little bit confusing, but this is a group. The first one is a group that contains everything that you exported from Blender or any other 3D software. So we need to add this to our scene. How we can do that? The same way as we are adding any other object. We're gonna call a scene.add and we're gonna pass GLTF a scene. Once we do that, let's refresh this one. We're gonna see our model, but it's fun because it's completely black. So yeah, if we want a black cat, that will be enough, right? And also I'm checking that we need also something else to move around. We need the orbit controls. The way to add orbit controls is similar to the GLTF loader. We need to import them from another place, which is examples, DSM controls and orbit controls. And then we can set it up pretty easy. Let me check how it was. It was after the render, yes, here. So we can go down here. When we create a render, okay? And after the render, we define controls. We can say, let's initialize it here. So it's gonna be LED controls, orbit controls. Okay, and once is experience value, we are going to use new orbit controls, and we need to pass the camera and the DOM element that is inside of the renderer, which in this case is the canvas. Also enable damping to better control. Okay. The last thing we will need to do on the loop itself is update the controls. Okay, so now we should be able to move around. That's pretty cool. Maybe we can move up the camera because it's way down. So now we have it. Okay, perfect. The reason that we cannot actually see our model is because there are no lights in our scene. Okay, before we were playing with a basic material in the sphere, and this material doesn't need any light to react to. But now that we have a proper GLTF model, we need to add something. We can add it just here, and the same way as you create spheres and so on, we can create a light. So I'm gonna create something that is called an ambient light. Okay, so it's using the constructor from ThreeJS called ambient light, and you pass two parameters. One is the color, and the other one is intensity. So if we save, sorry, we need to add it to the scene. I always forget. Something that happens often to me is that I forgot to add it to the scene, and then I go to the browser and I don't see why it's working and so on, why it's not working, so I had to go back and add it. Okay, so we add the ambient light, and now we kind of see something, but really dark, right? Maybe we can go up with intensity, so we will have something like this. That's better. I don't know if you notice though that whenever we here there is like these steps in the model, right? You see like a low definition, like if it's a Pokemon game. So what we can do is add to the render the pixel radio and pass the pixel radio from the Windows device. But since we want a minimum, okay, we want to set up a minimum, let's pass it there and set it as 2. So now your model should be way better. If we zoom in, zoom out, you're gonna see that there are not that many steps. It's in a better definition. Okay? And as easy as that, we can add our model to the scene. One last thing that we can do to improve our Nuxt application with the ThreeJS and our model here will be to extract this logic somewhere else, because right now we have everything in one file, right? So here is where composables can come handy. For example, we could create a composable that is called useModel that imports the GLTF and does everything for us there. Even we can add a promise to this so we can return it. Let's do that. Here I'm going to create a new folder called composables, and maybe I'm gonna zoom in a little bit because I resetted the zoom up here. So let's create one called use GLTF model. That will be a proper name for it. .ts. Okay, so what do we need? If we go to our experience, we can actually take this from here, okay? So we go back to use GLTF model. We can export a function called use LGL model. Okay, interesting. What is this function? Okay, Copilot, but give me something better. No, this is not enough. So yes, use loader. No, we are gonna use the one we have right now. So the GLTF loader, that's fine. And we can do here is create another function called function load model or load directly like this, okay? And return a new, oh my god, I love Copilot. Okay, so we return this load here, so we pass the URL. This should be the URL here. Actually, we can use the URL down here. So you use GLTF loader. We imported here in the beginning. So how it was imported? It's not autocomplete. Okay, so here, go back. So we load it from here, we create it, we can return it. So we return the load. And what we are interested in returning is, yeah, the promise, right? So we resolve it. It's gonna resolve the GLTF directly. If it's reject, we're not, yeah, we're gonna throw an error. I mean, we can do this a little bit better and add some try catch, but let's try it with this. I think it will work, right? So if we go to the experience, we can go down here and after the light, let's say const load equal to use loader, no, to use GLTF model, that's fine. And then, yeah, do something like this. A scene is gonna be model, that's fine. We are gonna deconstruct, if you remember, it was GLTF, like the callback, it was GLTF, and then the scene. So what we need to add is just a model here. It doesn't exist some type of no. Well, we have some typing issues that we will need to take care of, but let's see if this works. So if go here, it's gonna say error 404. Okay. So we're trying, yeah, this is not the correct one. This is a placeholder. So it's gonna be Nuxt and Nuxt, right? Like before. And voila! We have done it with a composable. So that's pretty useful because then we can use this loader in several scenes if we want. Make sure that take in consideration that they will share the same state, so be mindful about it, and also remember about the performance and the proxies. Your activity is based on proxies, so we cannot abuse of setting up the instances as reactive because we can compromise the performance. And with our Nuxt cat added successfully to our Nuxt application, we can say that this tutorial has reached its end. Today was pretty fun. I hope you have fun too. Please let me know in the comments any questions. The repo is going to be available on the description so you can download it and play with it. Don't forget to subscribe and drop a like if you want more content like this, and let me know in the comments what tutorials you would like to see next. If you want to see more 3D content, more Nuxt content, or a mix of both.